Hello, my dear students. Good afternoon. Welcome to the class. Myself, Bhagyashree Joshi from Sankalp Learning Solutions. Dear students, today we are going to discuss the chapter that is light reflection and refraction. That is in the science, uh, I think it is 9th or 10th chapter, right? So light reflection and refraction. So this is also very, very important chapter. And from this chapter, we are going to get 1 mark, 2 mark, 3 and 4 marks questions. Okay. Yes. So shall we start the class? Okay. So topic is light reflection and refraction. Then what do you mean by light? Light is a source of energy. Okay. It is one of the source of energy, or it is one of the forms of energy which helps us to see the object, right? How can you see the object? When see this is an object, right? When light falls on this object, when light falls on this object, then it reflects. See, if you are standing here, okay, you are standing here. Now light falls on this object, then light bounces back or it reflects back, right? So this reflected ray, when it reaches to our eyes, then we can see that object, right? When reflection occurs, when reflected ray reaches our eyes, then only we can see the object clearly, right? So in order to see the object, reflection is must, right? So what do you mean by reflection? Reflection means bouncing back of the light. So in reflection, so in this chapter, we are going to study about the reflection and refraction, right? Reflection and refraction. So already we have learned this chapter. Just we will revise it and we'll solve some multiple choice 2, 3, 4 marks questions. Okay. So in reflection, we are going to study about the reflection in the mirrors. Okay. Reflection in the mirrors. So which type of mirrors? That is in plane mirrors and reflection in spherical mirrors. Spherical mirrors. Reflection in plane mirror and reflection in spherical mirror. Plane mirrors means what? Day-to-day life we are using this only. Okay. So plane mirror means mirror, normal mirror, right? So spherical mirror. Spherical mirrors means what? If you take a sphere, when you cut this sphere into when you cut this sphere, you will get two parts, like right? So one part is like this and other part is like this. When this part is meant for the reflection and this part is coated, we call it as a concave mirror, right? When inward part is meant for the reflection and another part is coated, that we call it as a concave mirror. So concave mirror, right? So another mirror. So outward part, this is outward part, right? This is inward part and this is outward part. Outward part is meant for the reflection and another surface is coated. Such type of mirrors are called as convex mirror. Convex mirror. That means in spherical mirrors, we are going to observe two types of mirrors. One is concave mirror and another one is convex mirror. Okay. Next, laws of reflection. And also we are going to study about the formation of images. Okay. So image formation in concave and convex mirrors and nature and position of the image in concave and convex mirror. Okay. So next comes lenses. Okay. So next comes lenses. So here also we are going to observe two parts, two types, that is concave lens and convex lens. Convex lens. So concave lens is like this. So concave lens is like this. Okay. And convex lens is like this. So here If you do like this, ಈ ತರ ನೀವೇನಾದ್ರೂ ಮಾಡಿದ್ರೆ, both the surfaces are meant for refraction here. Okay, so no one surface is coated, so both the surfaces are meant for refraction. And in case of mirrors, only one surface is meant for the reflection, but in case of lenses, both the surfaces are meant for the refraction. Okay, and they are transparent material. ಇಲ್ಲಿ ಹೇಗಿರುತ್ತೆ, ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಮಟೀರಿಯಲ್ ಇರುತ್ತೆ. ಎರಡೂ ಸರ್ಫೇಸ್ ಅನ್ನ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ರಿಫ್ರಾಕ್ಷನ್ ಗೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, so that is about the concave lens and convex lens. So what is the difference between lenses and mirror? In the mirror, only one part is meant for the reflection, and in case of lenses, both the parts are meant for refraction and they are transparent. Mirrors are not a transparent. Okay, one part is coated, one part ಗೆ ನಾವು ಬಣ್ಣವನ್ನ ಹಾಕಿರ್ತೀವಿ, ನೋಡಿದೀರಾ ಅಲ್ವಾ? Have you observed the mirror? Right? Next one. So next comes refraction. What do you mean by refraction? In generally, refraction means what? Refraction means bending of light in different medium. So when light travels from rarer to denser medium, okay, so this is a denser medium, this is a rarer medium, okay, and this is a normal, then it bends towards the normal. When the light travels from denser to rarer medium, it bends away from the normal. Remember, refraction means what? Bending of light in different medium, right? One medium in the mattondu medium ge light barbekadre, it changes, means it bends. Okay, so that phenomenon we call it as a refraction. Okay, next, this is also very important. And here also, in case of lenses also, we are going to observe formation of images. Okay, formation of images in concave lens and convex lens. And next we are going to observe, that is sign convention. Sign convention. Okay, so this is very important, and it is used in numericals. Okay, sign convention, where we are using positive and where we are using negative. Okay, okay, sign conventions. And next part is magnification. So this is also important. Magnification and power of lens. Power of a lens, right? So magnification and power of a lens. Magnification means what? Ratio of the height of the image to the height of the object. See, if I consider height of the image is h dash and height of the object is h, then h dash divided by h is the magnification. Yeah. Okay, so that is magnification. Then power means what? It is the capacity of convergence or divergence. Okay, ಎಷ್ಟು ಕನ್ವರ್ಜಿಂಗ್ ಕೆಪಾಸಿಟಿ ಇದೆ, ಎಷ್ಟು ಡೈವರ್ಜಿಂಗ್ ಕೆಪಾಸಿಟಿ ಇದೆ, that is called as power of a lens. And power of a lens, P is equal to reciprocal of a focal length. Okay, remember. And SI unit of a power of lens is diopter. That is denoted by the letter D. Okay, diopter. Next, we'll solve some multiple choice questions. The focal length of a lens is 0.50 meter. The power of the lens and type are. Okay, so power of the lens and type are. So power of the lens is P is equal to 1 divided by F. Focal length they have given, that is 0.50. So 1 divided by 0.50. 1 divided by 1 divided by 0.50 means it is 2.0. Here plus 0.50 is there, therefore it is plus 2.0. When you get positive sign, it is a convex lens. So in case of convex lens, you are going to get positive sign. In case of concave lens, it is negative. Okay, so option A is right. ಎಲ್ಲಿ ನಿಮಗೆ ಪಾಸಿಟಿವ್ ಅಂತ ಬರುತ್ತೆ ಅದು ಕಾನ್ವೆಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಎಲ್ಲಿ ನಿಮಗೆ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ, where you are getting negative sign, that is concave lens. Okay, remember. The nature and the size of the image formed when an object is kept between the principal focus F1 and optic center O. So this is also important. Image formation, okay, in different position. When you keep an object in different position, where the image will occur. So this is important. When an object is kept between the principal focus F1 and center O. So of a convex lens are whether it is virtual, erect, or enlarged, real, inverted, and small size, virtual, inverted, and small size, real, inverted, and enlarged. Which option is right here? Virtual, erect, and enlarged. So this option is right. One property of a convex lens among the following is that it diverges the light rays, it is thicker at the edges and thinner at the middle, forms real and erect image, it is thinner at the edges and thicker at the middle. Yes, my dear students, the property of convex lens they have asked. ಏನು ಕೇಳಿದ್ದಾರೆ ನಮಗಿಲ್ಲಿ convex lens. Okay, so convex lens is like this. By looking only we can tell that it is thick at the middle and thin at the edges. Yes or no? Thick at the middle and thin at the edges. So which option is right here? It is thinner at the edges and thicker at the middle. Okay, it forms virtual and inverted image. Real and erect anta kottidare. So which correct option is it is thinner at the edge and thicker at the middle. Next one. Image formation by a concave mirror for different positions of the object. When you kept the object at infinity, which position you will get the image? At the focus F. This is very, very important. And the size of the image will be highly diminished and it is point size. Okay, just it is point size. And image is real and inverted. Real means we can get the image on the screen. Real and inverted. Virtual means behind the screen. Beyond C. Beyond C means when you kept object beyond C. C means center of curvature. Yes or no? The image will form between F and C and the size of the image is diminished. Okay. And nature of the image will be real and inverted. Remember, when you kept an object at C, then image will form at C only and it is of the same size, but it is real and inverted. Inverted means what? Ulta agi. Okay, so ulta. Erect means upright. Inverted means it is downward. Okay, so nimge object ee thara idre inverted alli he kansutte ee thara kansutte. Exactly ulta, right? So that is inverted. Between C and F. So between center of curvature and focal and principal focus F. So image will form beyond C and it is enlarged. Okay. Means enlarged means object kinta doddadagi form agodu, bigger than the object, right? And it is real and inverted. Next, at point F. F means what? Principal focus or focus. Then image will form at infinity. Ello ದೂರದಲ್ಲಿ ಆಗತ್ತೆ at infinity. Then it is highly enlarged. ಬಹಳ ದೊಡ್ಡದಾಗಿರುತ್ತೆ but ದೂರದಲ್ಲಿ ಆಗತ್ತೆ. So this is highly enlarged and the image is real and inverted. Remember, in all the cases it is real and inverted. When you keep an object between P and F, in that condition only the image will form behind the mirror. So this is important. When you kept the object between P and F, then the image will form behind the mirror and it is enlarged and it is virtual and erect. So behind the mirror, when you get the image behind the mirror, then it is called as virtual. When you get an image on the screen, then it is real. Okay, here we are getting image behind the screen. That is virtual and it is erect. Erect means what? Upright, straight agine sigatte nimge. That is virtual and erect. Next one. Nature and position and relative size of the image formed by a convex mirror. Okay. So convex mirror. Position of the object. When you kept a at infinity, then position of the image is at the focus F and it is behind the mirror. Okay. It is convex mirror. So image will form behind the mirror and it is highly diminished. It is point sized and it is virtual and erect. In case of convex mirror, we are going to get virtual and erect. So in case of concave mirror, in all the cases, real and inverted, but in only one case between P and F, in that condition only virtual and erect. Otherwise, rest all real and inverted. But here, At infinity, at the focus F behind the mirror, it is highly diminished point size and nature of the image is virtual and erect. Between infinity and the pole P of the mirror, that is between P and F behind the mirror, where you will get the image that is behind the mirror, and it is diminished and it is virtual and erect. Okay. Next, uses of concave mirror. Uses of concave mirrors. So concave mirrors are commonly used in torches, searchlights, vehicle, okay, searchlight, vehicles, headlight, shaving mirror. In dentist uses concave mirror. So why they are using concave mirror? Because by using concave mirror, you can see the object big. So okay, object is enlarged. For that reason, they are using concave mirror. So ನಿಮ್ಗೆ ಡೆಂಟಿಸ್ಟ್ ಹತ್ರ ಹೋದ್ರೆ ಹಲ್ಲನ್ನ ನೋಡುವಾಗ ಅವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ, ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿ ಕಾಣಬೇಕು ಅಂತ they are using concave mirror, right? In case of headlights also, so ದೊಡ್ಡದಾಗಿ ನಿಮ್ಗೆ ಜಾಸ್ತಿ ಬೆಳಕು ಬೇಕು. So in that condition, they are using concave mirror, right? Uses of convex mirror. So where we are using convex mirrors? So convex mirror are used in vehicles and rear view mirror. In vehicles ಅಲ್ಲಿ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀರಾ? ರೇರ್ ವ್ಯೂ ಮಿರರ್. ಸೊ ನಮ್ಗೆ ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ, ದಟ್ ಇಸ್ ರೇರ್ ವ್ಯೂ ಮಿರರ್. ಸೊ ಹಿಂದೆ ಬರುವಂತಹ ವೆಹಿಕಲ್ ವಿ ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದ vehicle clearly. So for that reason, we are using convex mirror here. So convex mirror, in case of convex mirror, we can observe the object. ದೊಡ್ಡ ಆಬ್ಜೆಕ್ಟ್ ಇದ್ರೂ ಕೂಡ ನಮ್ಗೆ ಸ್ಮಾಲ್ ಆಬ್ಜೆಕ್ಟ್ ಕಾಣಿಸುತ್ತೆ. ಹಿಂದೆ ನಮ್ಗೆ ಬಸ್ ಬರ್ತಾ ಇದ್ರೆ ದೊಡ್ಡ ಬಸ್ ಕಾಣಿಸಲ್ಲ, ಪೂರ್ತಿ ಬಸ್ ಕಾಣಿಸುತ್ತೆ, ಬಟ್ ಇಟ್ ಈಸ್ ಇನ್ ದ ಸ್ಮಾಲ್ ಸೈಜ್. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ದ ಸ್ಪೆಷಾಲಿಟಿ ಆಫ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್. ಮಿರರ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಇನ್ ವೆಹಿಕಲ್ಸ್, ದಟ್ ಈಸ್ ರೇರ್ ವ್ಯೂ ಮಿರರ್. List 4 characteristics of the images formed by plane mirrors. Okay, plane mirror. In day-to-day life, we are using plane mirror. ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತೀರಾ? ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ತಲೆ ಬಾಚ್ಕೊಳ್ಳೋಕ್ಕೂ ನಾವು ಪ್ಲೇನ್ ಮಿರರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ನಮ್ಗೆ ಮೇಕಪ್ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೂ ಪ್ಲೇನ್ ಮಿರರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ರೈಟ್? ಸೊ ದಟ್ ಈಸ್ ಪ್ಲೇನ್ ಮಿರರ್. Characteristics of the image formed by a plane mirror are, that is, image distance is same as that of the object distance. Okay, image distance ನೀವೆಷ್ಟಿರ್ತೀರಾ ನಿಮ್ಮ ಇಮೇಜ್ ಕೂಡ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಸೊ ಇಫ್ ಯು ಆರ್ ಸ್ಮಾಲ್, ದೆನ್ ಇಮೇಜ್ ಇಸ್ ಆಲ್ಸೋ ಸ್ಮಾಲ್. ಇಫ್ ಯು ಆರ್ ಬಿಗ್, ದೆನ್ ಇಮೇಜ್ ಇಸ್ ಆಲ್ಸೋ ಬಿಗ್. ಇಫ್ ಯು ಆರ್ ಹೈಟ್, ದೆನ್ ಇಮೇಜ್ ಇಸ್ ಆಲ್ಸೋ ಹೈಟ್. ಓಕೆ, ದಟ್ ಮೀನ್ಸ್ object and image distance are same. Okay, next, image formed is virtual and erect. Virtual means what? You are getting the image behind the screen, right? Behind the screen. So for that, virtual and erect. Erect means upright image you will get. So ನೀವು ಸ್ಟ್ರೇಟ್ ಆಗಿ ನಿಂತ್ಕೊಂಡ್ರೆ ಅದು ಕೂಡ ಸ್ಟ್ರೇಟ್ ಆಗಿನೇ ಇರುತ್ತೆ ನಿಮ್ಮ ಇಮೇಜ್. ಏನಾದ್ರೂ ಅದು ಉಲ್ಟಾ ಆಗತ್ತಾ? No. That means if you are standing straight, then image is also erect, that is upright. Image formed is of the same size as that of the object. ನೀವು ಯಾವ ತರ ಇದ್ದೀರಾ ಅದೇ, ನೀವು ಸಣ್ಣಗಿದ್ರೆ ಅದು ಸಣ್ಣದಾಗಿ ಕಾಣಿಸುತ್ತೆ, ನೀವೇನಾದ್ರೂ ಸಣ್ಣಗಿದ್ರೆ ಅದು ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತಾ? ಇಲ್ಲ. ಸೊ image is same as that of the object. That means size of the image is same as that of the object. Okay. Image formed is laterally inverted. What do you mean by lateral inversion? When left appears right and right appears left. ನೀವೇನಾದ್ರೂ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಅನ್ನ ಎತ್ತಿದ್ರೆ ನಿಮ್ಗೆ ಏನ್ ಕಾಣಿಸುತ್ತೆ? ರೈಟ್ ಹ್ಯಾಂಡ್ ಕಾಣಿಸುತ್ತೆ. ರೈಟ್ ಹ್ಯಾಂಡ್ ಅನ್ನ ಮೇಲೆತ್ತಿದ್ರೆ ಯು ಆರ್ ಅಬ್ಸರ್ವಿಂಗ್ left hand, right? So left appears right, right appears left. That is lateral inversion, laterally inverted, right? Next, when an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror. This image is, so here you are keeping the object within focus of a concave mirror, an enlarged image is formed behind the mirror. This image is, so behind the mirror, mirror idre ಏನ್ ಸಿಗತ್ತೆ ನಮ್ಗೆ? If you are getting the image behind the mirror, that means behind the screen you are getting the image, that means that is virtual image, right? So virtual and erect, you are using behind the mirror, so that is virtual and erect. When an object is placed between the principal focus and the pole of a concave mirror and enlarged, that means between F and P and F, right? So between F and P. Then you are observing the image behind the screen, that is virtual and erect. Remember, an enlarged virtual and erect image is formed behind the mirror. Therefore, option D is right here. Reason is this one. Next, draw a labeled ray diagram to show the path of the reflected ray corresponding to an incident ray of light parallel to the principal axis of a convex mirror. Mark the angle of incidence and angle of reflection on it, right? So here, this is a convex mirror, right? And this part is coated and reflection occurs at this point. Now what they have asked here, incident ray of light is parallel to the principal axis. This is principal axis. Now the ray of light is parallel to the principal axis. Okay, when it is parallel to the principal axis and it is a convex mirror, after reflection, when it touches the convex mirror, here reflection occurs. After reflection, where the light will go? In this direction it will travel. Okay, so ಅದೇನಾಗುತ್ತೆ ಈ ತರ ಹೋಗುತ್ತೆ. ಈ ತರ ಹೋದಾಗ, so when you drag this line, you will get principal focus at this point. Okay, at this point. And when you draw a normal, that is center of curvature, we will call center of curvature. Okay, so this is, okay, this we will call center of curvature and this is F. Okay, see, if you drag this line, then this is F, principal focus F, and if you draw a normal, when you drag this normal, then it is center of curvature C. Okay, now see here, this is the angle of incidence. Why you are drawing normal? So when, see, this is a smooth surface and light is, this is incident ray and this is reflected ray. When you draw a normal, clearly you can see incident angle, angle of incidence, that is I, and angle of reflection, angle R. And angle of incidence is equal to angle of reflection, that is I is equal to R. These two are equal. That is the law of reflection. Okay. So these two angles are equal. Angle of incidence is equal to angle of reflection, and angle of and incident ray, reflected ray, and the normal appears on the same plane, right? Next, principal axis of a convex mirror. Mark the angle of incidence and angle of reflection. So that is angle I and angle R. These two are angle of incidence and angle of reflection. Okay. An object is placed at a distance of 30 centimeter in front of a convex mirror of focal length 15 centimeter. Write 4 characteristics of the image formed by the mirror. So 4 characteristics of the image formed by the given convex mirror. So it is a convex mirror. In case of convex mirror, it is virtual and it is erect and diminished. Image is always formed behind the mirror between pole and focus. Okay. So these 4 characteristics are there for convex mirror. Next, what would be the angle of incidence for a light ray having 0 reflection angle? So angle of I is equal to angle of R. Okay. So right, having 0 angle reflection angle, that means R is equal to 0. When R is equal to 0, then I is also equal to 0. Why? Because I is equal to R. Angle of incidence is equal to angle of reflection by law of reflection, right? So if R is equal to 0, then I is also equal to 0. Therefore, it is 0 degree. Right? It is 0 degree. A full length of the image of a distant tall building can be seen using, yes, ಒಂದು ದೊಡ್ಡ ಟಾಲ್ ಬಿಲ್ಡಿಂಗ್ ಇದೆ, that ಬಿಲ್ಡಿಂಗ್ ಅನ್ನ ನಾವು ಏನ್ ಮಾಡ್ಬೇಕು, ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೇಕು. ಅದು ಯಾವ ಮಿರರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀರಾ? Yes, full length of the image of a distant tall building can be seen using a convex mirror, plane mirror, a concave mirror, and none of the options. So which mirror you are using? A convex mirror, right? The ratio of the sine of angle of ratio of the sine of angle of incidence, wait for a minute, angle of incidence to the angle of and angle of incidence to the sine of angle of refraction is constant, then it is given by which scientist has given this law? That is Faraday's law, Snell's law, Newton's law, Murphy's law. That is Snell's law. Okay. Sin I divided by sin R, right? Sine of angle of incidence divided by sine of angle of refraction is equal to constant. This constant is called as refractive index. Constant, right? Sin I divided by sin R. This is Snell's law. Snell's law. So option B is right. Now, twinkling of stars. Twinkling of stars is due to which optical phenomenon? Whether it is reflection, interference, refraction, or divergence. So this is refraction. Okay. The laws of reflection are valid for a convex mirror, plane mirror, concave mirror, all mirrors irrespective of their shape. So this is all mirrors irrespective of their shape. Light from the sun falling on a convex lens will converge at, okay, light from the sun falling on the convex lens will converge at, so nimgilli, here sun is there and you are, and the light is coming like this. Okay. After refraction, the rays will converge at this point, that is F. Okay. So which that we call it as a focus, radius of curvature, optical center, focus, none of the above. So that is focus. So rays will converge at a particular point. That point we call it as a principal focus. Yes or no? Yelli ella rays ಒಂದೇ ಕಡೆ meet ಆಗತ್ತೆ. That point we call it as a principal focus, or it is F. Focus F, right? Next, the magnification produced by a spherical mirror is -3. The list 4 informations you obtain from this statement about the mirror or image. Okay, so negative sign of magnification indicates that the image is real. Okay, negative indicates this is a real and it is inverted. Real and inverted. Remember, when magnification is negative, then it is real and inverted. This is very, very important. Remember, since the image is real and inverted, mirror is concave mirror. So if you get negative sign, then it is concave mirror. So in concave mirror, real and inverted image you will get. And magnification of -3 indicates that image is magnified. -3 in indicate ಮಾಡುತ್ತೆ, image is magnified, right? Draw a ray diagrams for the following cases when a ray of light passing through the center of curvature of a concave mirror is incident on it. Parallel to the principal axis is incident on a convex mirror and it is passing through the focus of a concave mirror incident on it. So this question was asked in 2020, right? So first, ray of light passing through the center of curvature. So what is center of curvature? See, if you take one sphere and this sphere, it has one center, right? So this center, we call it as a center of curvature. Okay. So ನಿಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ, ಇಲ್ಲಿ ಇಷ್ಟೇ ಪಾರ್ಟ್ ಇದೆ. Only this part is there. ನಿಮ್ಗೆ ಅನ್ಸುತ್ತೆ center of curvature ಹೇಗೆ ಬರುತ್ತೆ ಅಂತ. So if you take only this part, then this is also a part of the sphere, right? So when you complete this, then you will get sphere only. Then center of the sphere, we call it as a center of curvature, C. Okay. Now the ray of light is passing through the center of curvature. Center of curvature in the light ಏನಾದರೂ pass ಆದ್ರೆ ಅದು ಹೇಗೆ ಹೋಗುತ್ತೆ? It travels in the same direction as that of the incident ray. So ಅದೇ ಅಂದ್ರೆ ಇದೇ direction ಅಲ್ಲಿ ಮುಂದೆ ಹೋಗುತ್ತೆ. So ಅಂದ್ರೆ change ಮಾಡಲ್ಲ. It cannot change its path, right? So like this. Then P means what? Pole. Pole means what? Center of the reflecting surface. See, this is a reflecting surface and center of this part we call it as a P. A ray of light parallel to the principal axis is incident on the convex mirror. After reflection appear to diverge from the principal focus of a convex mirror. So here we are taking convex mirror. So this is concave mirror and here we are taking convex mirror. So convex mirror is like this. And this part is reflecting surface and here the light is parallel to the principal axis. So when it touches the reflecting surface, the light will travel in this direction and it appears to meet at this point. Okay, that point we call it as a F. So in case of convex mirrors, exactly rays will not meet, but it appears to meet. ನಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ ರೇ ಹೇಗ್ ಹೋಗುತ್ತೆ ಹೀಗ್ ಬಂದು ವಾಪಸ್ ಮೇಲೆ ಹೋಗುತ್ತೆ ಅದು ಮೀನ್ಸ್ ಅದು ಡೈವರ್ಜ್ ಆಗತ್ತೆ ಬಟ್ ನಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ ಅಲ್ಲಿ ಹಿಂದ್ಗಡೆ ಹೋಗಿ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮೀಟ್ ಆಗತ್ತೆ ಅಂತ ನಮ್ಗೆ ಅನ್ಸುತ್ತೆ ದಟ್ ಮೀನ್ಸ್ ಅಪಿಯರ್ಸ್ ಟು ಮೀಟ್ ಅಟ್ ಪಾಯಿಂಟ್ ಎಫ್ ರೈಟ್ ಸೊ ಅಪಿಯರ್ಸ್ ಟು ಮೀಟ್ ಅಂತಂದ್ರೆ ನಮ್ಗೆ ಅನ್ಸುತ್ತೆ that it is meeting at this point, right? That is F, and P is pole and C is center of curvature, right? So this is the ray diagram for light parallel to the principal axis. Okay, next. Ray of light passing through the focus of a concave mirror after reflection will emerge parallel. So here this is passing through the focus and after reflection it is passing parallel to the principal axis like this. Okay. Next one. Concave mirror has a focal length 20 centimeter. At what distance from the mirror should a 4 centimeter tall object be placed so that it forms an image at a distance of 30 centimeter from the mirror? Also calculate the size of the image formed. So size of the image formed is we don't know, right? So here focal length is 20 centimeter. Here we are using concave mirror, right? So in concave mirror alli, see this is an incident light. Okay, after reflection where it goes like this, right? So it meets at this point, that means it converges, light will converges or it meets at this point, therefore principal focus is at this point. Yellide adu at the same side of the object. See, if object is here and image will also form of this image will also form here only. That means object allide ade ಒಂದು side alli image kuda form ಆಗುತ್ತೆ, right? So here this is positive. If image is formed on the right side idre this is positive, this is negative. If image is upward then it is positive and image will be downward then it is negative. Okay, ಕೆಳಗಡೆ idre that is negative, ಮೇಲಿದ್ರೆ that is positive, right hand side idre that is positive and left hand side idre that is negative. Now here focal length, so this is P and this is F. The distance between P and F is small f, focal length. F is negative here, so minus 20 centimeter. And V is so image at a distance of 30 centimeters. So image distance we know that is V. V is minus 30 and object distance we don't know, that is U. Okay. Image distance we know. Minus 30. Why minus 30? Because image will form on the left hand side. So that is negative. Therefore, we took it as a minus 30. So mirror formula 1 divided by V plus 1 divided by U is equal to 1 divided by F. So 1 divided by U we don't know. So transfer this V to this side. That is 1 divided by F minus 1 divided by V is equal to 1 divided by F value is minus 20 minus 1 divided by V value is minus 30. So this is 1 divided by minus 20 minus into minus plus 1 divided by 30. So 20 and 30. 20 and 30. So LCM is 10 2s are 10 3s are. So this is 2 and this is 3. So 10 2s are 20, 20 3s are 60. So 60 is the LCM, right? So 60 means 23s are 32s are. Right? So 1 into 3 is 3. That is minus 3 because here minus sign is there. So minus 3 plus 1 into 2. That is 2. 3 minus 3 plus 2 is minus 1 divided by 60. So minus 1 divided by 60 means this is the value of 1 divided by U. Then what is the value of U? U is minus 60. 1 by U is 1 divided by minus 1 divided by 60. Then what is U? reciprocal, that is 60, minus 60. Object is placed at a 60 centimeter from the mirror. So 60 centimeter means what? Object is placed at a 60 centimeter from the mirror. So this is concave mirror, and obviously object is placed on the left hand side. Therefore it is negative, minus 20. Also magnification. Magnification is M is equal to H dash divided by H. Height of the image divided by height of the object. If they give height of the image, then you can use this formula, or minus V divided by U. V, V is the image distance and U is the object distance. Here we know image distance, and also we know the object distance. Image distance is minus of minus 30, minus image distance is minus 30 divided by U is 60 here, right? Minus 60. Minus into minus, it is plus 30 divided by minus 60 into 4. So 0, 0, 3 ones are 3 twos are, 2 ones are 2 twos are. So this is minus 2 centimeter. Size of the image is 2 centimeter. Why? Minus 2 centimeter means here image is formed on the left side, therefore it is negative, but size of the image is 2 centimeter. Okay, 2 centimeter. This question can be asked for 2 marks. Okay, next. An object 4 centimeter in height is placed at a 15 centimeter in front of a concave mirror of focal length 10 centimeter. At what distance from the mirror should a screen be placed to obtain a sharp image of the object? Calculate height of the image. So height of the image we need to calculate. What they have given? See, this is a concave mirror. Here also we are using concave mirror. Right? Concave mirror means obviously object is on the left hand side and image is also on the left hand side. And what they have given, object is placed at a 15 centimeter. That means object distance they have given, that is minus 15 centimeter. Minus because it is on the left hand side. Therefore it is minus 15 centimeter. And object height h they have given, that is 4 centimeter. And focal length they have given, that is f is equal to minus 10 centimeter. Okay, why? Because image is also on this position. So this is P and this is F. So this is capital F and this is focal length. So focal length means image is, it is on the left hand side. Therefore it is negative, minus 10 centimeter. Then image distance is V is equal to question mark. By using image mirror formula, 1 upon V plus 1 upon U is equal to 1 upon F. So 1 upon V plus, here we know the value of U, but we don't know V. So 1 upon F minus 1 upon U. So 1 upon F value is minus 10 minus 1 upon minus 15. So 1 upon minus 10, minus into minus plus 1 upon 15. So 10 and 15. 10 and 15 LCM is 30, right? So 10 and 15 LCM is 30. So 5 U 2s are, 5 U 3s are. Then 2 and 3. 5 2s are 10, 10 3s are 30. Therefore LCM is 30. Then here it is 3 into 3 into 2. 3 minus 3 plus 2. Therefore, it is minus 1 divided by 30. So, minus 1 divided by 30 means minus 3 plus 2 is minus 1 divided by 30. This is the value of 1 upon V. Right? Then what is V? V is minus 30. Yes or no? V is minus 30. In order to obtain a sharp image of the object on the screen, screen should be placed at a distance of 30 centimeter in front of the mirror. So, namge sharp image bekadre, navelli idbeku. So, screen should be placed at the distance of 30 centimeter front of the mirror. Okay, minus irodrinda left side igene irbeku. So, here we will keep them, we will keep the screen, right? Also, magnification M is equal to H dash divided by h. So object ಅನ್ನು ನಾವು ಎಲ್ಲಿ ಇಡಬೇಕು, ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಗೆ ಇಡಬೇಕು. ಓಕೆ, ಸೊ m is h dash divided by h. H dash is minus v divided by u and h dash value is height of the object. Height of the object they have given, that is 4. Okay. So height of distance image distance is minus of minus 30 divided by minus 15. U is minus 15. So h dash is equal to, transfer this 4 to this side, then it is 30 into 4 divided by 15, right? Now, minus into minus, it is plus, but it is minus. So minus 30 into 4 divided by 15. Now 15 ones are 15 twos are, right? Minus 2 into 4. This is minus 8. Thus the height of the image is 8 centimeters. So image is also formed at this, image is also form on the left side. Therefore it is negative and height of the image is 8 centimeter. What is meant by a power of lens? The power of lens is a measure of the degree of convergence or divergence of a light ray falling on it. The power of a lens is defined as the reciprocal of its focal length in meter. So what is power of lens? Power of a lens is degree of convergence, divergence. Degree of convergence or divergence. So power of lens P is equal to 1 divided by F. So F is focal length in meter. SI unit of the power is diopter, that is denoted by the D. 1 diopter is the power of a lens whose focal length is 1 meter. Right? Next one. The diameter of the reflecting surface of a spherical mirror is called its aperture. That we call it as an aperture. Remember. The angle of the incidence I and refraction R are equal in a transparent slab when the value of I is 0. Right? When the incident ray falls normally on the glass slab, it will refract it without deviation. That is along the normal in the glass slab. That is angle I is equal to angle R is 0. Divergent lens will produce always real image, always virtual image, both real and virtual image, and none of the above. Divergent lens will produce. Okay. Divergent lens means which lens you are calling as a divergent lens? Okay. In case of mirrors, so this is a concave mirror and this is a convex mirror. Yes or no? Okay. This is a convex mirror. Now this is a reflecting surface and here it is a reflecting surface. Now after reflection, it converges at this point. So this is a converging mirror. Converging mirror. Which is converging mirror? Concave mirror is converging mirror. But and diverging mirror is convex mirror is diverging mirror. Convex mirror na ಏನಂತ ಹೇಳ್ತೀವಿ? This is a diverging mirror. But in case of lenses, what happens? In case of lenses, this is a convex lens and this is a concave lens. So here, exactly opposite. Concave lenses are called as diverging mirror. So idರಲ್ಲಿ ನಾವು ಇದನ್ನ ಏನು ಹೇಳ್ತೀವಿ? Concave lenses are called as diverging lenses. And convex lenses, convex lens are called as converging. Here it is diverging, but here it is converging. Converging lenses. Okay, converging lenses. And concave lenses are called as diverging lenses. Exactly opposite. Okay, remember. Yes, diverging lenses will produce always real image, always virtual image, and both real and virtual image, none of the above. So always virtual image, that is diverging lenses will always forms a virtual, erect and diminished image. Okay, remember. So option B is right. Yes, my dear students, today we discussed about the light and What do you mean by reflection, refraction, and also we saw some multiple choice question. In the next class, we are going to discuss about the 2 marks, 3 marks, and 4 marks questions. Okay. Shall we stop today's session? Yes. All the very best. Thank you. Thank you so much.